identity is an equation that is always true. An identity is an equation that is always true for any values. So you know how sometimes you solve a problem and you get infinitely many solutions? It kind of means that that problem is an identity of some sort. Another thing we usually call identities is formulas. Formulas are equations that are always true, right? Anyway, we're going to learn a lot of identities in this class. So the first ones we are learning about today are called the reciprocal identities. And these seem pretty obvious, but you're going to use them a lot. The reciprocal identities are that the cosine of an angle is equal to 1 over sine. And the secant, did I say cosine because I meant cosecant? Okay. And the secant of an angle is 1 over cosine. And the cotangent of an angle is 1 over tangent. That allows you to change anything that's accidentally written in secant, cosecant, or cotangent form into sine, cosine, or tangent instead. And that usually makes it easier to work with, depending on what you're doing with it. Another thing that's kind of a fundamental identity that I think is officially not learned today, but I think it's maybe a good time to teach you about it. Let me see. Yeah, let's go ahead and talk about it right now. I think it will show up later, but we might as well do this one. Tangent can also be written as sine over cosine. This is not a reciprocal identity, and I can't find where I have it written to remember what it's actually called. But that's one that we will use a lot. Because it will be, you will see how essential it is at some point to be able to turn anything that's not sine and cosine into sine and cosine. So basically, here's all 4 of the other trig ratios turned into something involving sine and cosine. In fact, we could rewrite cotangent as cosine over sine, because it's the reciprocal of tangent. So therefore, everything can be written in terms of sine and cosine. That will come in handy in the next chapter, I think. But just something to start getting into your head now. Okay. Let's go ahead and do an example of some problems that you might do using this stuff. Shall we? Find the value of all 6 trig functions for an angle alpha in standard position and the terminal side goes through the point 2, -1. Okay, I'm just going to give you a second to digest that. Or copy it if you're copying it down or whatever. Okay, let's dissect this piece by piece here. Find the value of all 6 trig functions. So that means sine, cosine, tangent, cosecant, secant, cotangent. Angle alpha in standard position. What does standard position mean? So the vertex is at 0, 0. The initial side is on the positive x-axis, and the terminal side is somewhere wherever the angle's pointing, right? Now the last piece tells us the terminal side goes through the point 2, -1. Let's draw a picture first. That's my first step always. Step 1, sketch it. I don't understand how people can handle doing trig without sketching it, because I just have to have that picture to see it. I guess I'm just a visual learner, so I have to have it. Okay, so we want to go through the point 2, -1. I'm going to make my points kind of big just so my picture's not microscopic. So there's the terminal side of the angle, there's the initial side of the angle. So technically the angle is right there, right? It's an angle in quadrant 4, that means it's like probably 300 and something degrees. But we don't even care about the number of degrees. We couldn't care less, okay? Now, I kind of talked about this earlier, but this is something you're going to have to get used to. No matter what angle your quadrant is in, you're always going to turn it into a right triangle by drawing a vertical line to the x-axis. So when we looked at this one earlier, I drew a line down from that point down to the x-axis. What do I have to do in quadrant 4 in order to turn it into a right triangle? I need that line to go up to the x-axis and create my right angle that way, correct? Okay, so now since this is going through this point right here at 2, -1, what's the length of x? What's the length of y? It's technically 1, but you know what? We're still going to deal with we're going to leave positives and negatives in these problems, which gets a little confusing, because usually we think of it as a distance when we use Pythagorean theorem. But in this case, the -1 tells us what quadrant it's in, sort of. So we have to leave that negative there. Okay, what other number are we going to need? R. We are going to need R. So the next step, so I kind of sketched and labeled my picture with the numbers that I knew, correct? Okay, so the next step is going to be to find R. Can anyone think of a formula that would allow us to find R? Using Pythagorean theorem. Good job. Okay, so we'll have x squared plus y squared equals r squared, basically. So x is 2 squared, and y is -1 squared, and we're finding r squared. So that gives us 4 plus 1 equals r squared, so r squared equals 5. So what is r? Square root of 5. Did I go too fast? Okay, now that we know what r is, our last step is to just go ahead and do your ratios using the stuff we learned today. This stuff right here. Okay? Find the ratios. Okay. So sine is y over r. So what's sine going to be? -1 over square root of 5. Now, is there a problem with that answer? Square root of 5 is in the denominator. It's improper. What do we do about it? We sort of like square it by taking that number and multiplying it on the top and the bottom, right? So that gives us negative square root of 5 over 5. So there's sine. I don't know if I left myself enough room in this little corner here. Cosine. What's cosine? Cosine is what? X over r? So x over r, what was the x value? 2. What's the r value? Square root of 5. Rationalize it. 2 square root of 5 over 5. Okay, tangent is y over x. So -1 over 2, -1/2. Good? Okay, now we just flip those all around. So cosecant is going to be square root of 5 over -1. Doesn't need rationalized, and that just means the square root of negative square root of 5, correct? Does that make sense? And then secant will be square root of 5 over 2, which doesn't need rationalized, so that's it. And then cotangent, we just flip over the negative 1/2. So 2 over negative 1, which is what? A negative 2. There's our 6 answers for that triangle.